All right, so you learned what we called the altitude on the hypotenuse theorem using similar triangles, which can be super cumbersome and actually take a long time to figure out orientation. I'm going to do this one really quickly. So x, y, let's say that this were 3. Oh, actually, hold on. I'm going to go ahead and change these side lengths to be 3. We're going to make them a little smaller, and 7, if you're okay with that. So let's mark this up as 3 and dB is 7. We'll call this missing side length D. So if I reoriented our big triangle, all right, if you want to write big in here, you can. This side length would be 10, 3 plus 7. We have a Y here, an X, a right angle, a C, A, B. All right, we have our smaller triangle here. Let's call this our left triangle. If I reoriented that, I would get my Z, my X, and 3, D, A, C. Now remember my A's are congruent, so I'm going to mark those congruent. My right angle is here, and by angle, we know those must be the same. And finally, we have this right triangle. Now already, some of you probably have your head spinning, and I'm doing this quickly on purpose just to show that it's tedious. It takes a while if you're really thinking through corresponding angles and their congruencies. So those would be congruent. We know those are congruent. This takes forever, and then you have to start to set up proportions. Like if you're looking for x, you could say like x over 3 equals 10 over x. That could help you solve for your x value, right? X over 3 equals 10 over x, cross multiply, x squared equals 30. It's not bad. In fact, you know what you're doing. You know how to set up similar triangles. It's just tedious, and it takes a long time. So you ready to cheat? We're going to give you a little shortcut. This is called Parachute Pete. It's kind of silly, but I think that the shortcut helps kids do these problems probably in a third or quarter less time. So this is what we're going to say here. We got this little man Pete. Here he is. And he's always going to land on the right angle of the big triangle. Okay? So he has 3 options here when he lands on that right angle. He can slide down the altitude. He can slide down this leg, or he can slide down this leg, almost like going down a mountain. Okay? And after he makes the slide, let's say he makes the slide down the altitude, he has 2 places to walk. He can walk to A, or he can walk to B. Okay? If Pete were to slide down this leg, he can walk the length of dB, or he can walk this full length. Those are his 2 options. And finally, if Pete were to slide down this leg, he can walk the length of AD, or he can walk the full length. So stay with me. This is a silly saying, but we're going to go ahead and call this his slide squared equals walk times walk. This works every time. Gives us the same setup as all the similarity. It's just it really is a little bit of a cheat and a memorization tactic, so we don't have to do similarity every time. So watch this. Here we go. Pete slides down CB. So that's his slide. We're going to say CB squared equals, he can walk the length DB, so DB squared, times, he can walk the whole length, which is AB. Whoops, sorry, not squared. Slide squared equals walk times walk. You only square the slide. All right, or Pete could slide down here. CA squared. So here's my slide squared equals walk AD times walk AB. And his last option for sliding is he can slide down the middle. So we would get CD, slide squared, equals, now when he's in the middle, he can only do 2 short walks. DB times DA. As a math teacher, we don't love this approach because it really is memorization. That's why we start with the similarity day, so we understand why. We recognize the tediousness of the similarity, and then we say, hey, why don't we use this little shortcut to help us? So let's try a couple problems, see what you guys think. So looking at this first example, if AD equals 8, so that's down here, AD, and DB equals 4, find CA. Well, I'm going to put a little X on here if you guys are okay with that. CA. CA is my slide, right? So if Pete were to land, he always lands on the right angle of the big triangle. we'd have a slide squared. I'm going to write this only once. Slide squared, totally unmathematical, equals walk times walk. His slide is the x, right? So slide squared. His first option to walk is 8. Walk times his second option to walk is the full length, which is 12. All right, so we get x squared equals 8 times 12 is 96. I'll go ahead and square root both sides. We get a plus or minus, but we only care about the positive side length. The largest perfect square that goes into 96 is 16. Square root of 16 is 4, so we get that missing side length to be 4 root 6. So much quicker than setting up those similar triangles. Let's go ahead, let's try a few more together. All right, on this problem, they give me CB equals 10, so that's somewhere Pete would slide, right? So that's a slide. They say DB equals 4, and what I'm missing is this little piece here. Now, if Pete slides down 10, slide squared equals walk times this whole walk. So if I can find this missing length x, then I can certainly find AD, right? So here we go, slide squared. Slide squared, Pete's sliding down 10. He can walk 4, walk times, or he can walk the whole walk, x. Be careful, if you put your x here, you're not going to get the correct calculation, right? Because he can walk short or long. So here we get 100 equals 4x. All right, and we get x equals 25. So if this length is 25, then by subtraction, we get our missing side length here to be 21. Go ahead, I want you to pause the computer and I want you to try C and D on your own. See how it goes. All right, hopefully you marked up your diagram. CB is 8. They actually give me this whole length here, which is 10. My unknown is DB, which is one of my walks, so I'm going to go ahead and mark that as 8. I'm going to remind you again, he's sliding down here. Slide squared equals walk times walk. So in this case, we'd get 8 squared equals walk times walk. 64 equals 10x. Divide both sides by 10. That reduces to what? 32/5. And that's the length of our missing side. All right, let's try another. CD equals 6 root 3. So this is the case where he slides down the middle. DA equals 6. And they want me to find a lot of missing pieces, but let's start by marking this one as x, because when Pete slides down here, his slide squared is going to be, well, he can walk this way or this way. So this is kind of different than the other two. So slide squared, 6 root 3 squared equals walk times walk. When I square that first, be careful, lots of errors occur here. 36 times 3 equals 6 times x. So I get a 108 equals 6x. Divide both sides by 6. That goes in 18 times. So I find this missing side length to start to be 18. All right, now let's just take note. They wanted me to find CA, DB, which I just found was 18, and CB. Okay, so we have a little more work to do. So if I want to find CA, I have to slide again. You ready? Let's call this a different letter. How about we just call this side length A? Slide squared A equals, good thing I have these other side lengths, walk times walk. So in this case, I'm going to get a 6. Make sure you don't do 6 times 18. The full walk is actually 24. All right, 6 times 24 is 144. That's kind of nice. All right, perfect square. So A equals 12. So now we found CA to be 12. And finally, the last length that we're looking for is CB. Let's call CB, I don't know, anything you want. Let's call it Y, how about? So again, we have a slide squared equals walk times the whole walk. So we have a Y squared, slide squared equals 18 times. Biggest mistake kids will make is they'll make it an 18 times 6. But you know that the first walk is 18, the second walk is the full thing, 24. So we get a y squared equals the square root of 432. I want you to find the largest perfect square right now. That goes into 432. All right, I hope you found it to be 144. So 144 times 3, and we get that missing side length to be 12 root 3. So CB would be 12 root 3. Takes a little bit of time, but can you imagine doing that one with similar triangles? It really could be tedious, so this little trick will actually just come in handy for speed. So there's a lot of extra practice problems. We can put all the answers in here by the end of the video, but let me pick out a couple tricky ones for us. Actually, for the sake of time, I'm just going to show you the answers to a few more on the back side so you can practice. No work included, and then you'll practice these concepts in class. Good luck.